Next topic we have is basic postulates of Boolean algebra. See, the fundamental laws of Boolean algebra is called as basic postulates of Boolean algebra. Fundamental laws of the Boolean algebra is called basic postulates of Boolean algebra. Fundamental laws of Boolean algebra is called as basic postulates of Boolean algebra. Now we will discuss Boolean postulates. Boolean postulates. So each Boolean postulates we have to discuss here. See, the first one, what we have is, first one, if x not equal to 0, then x is equals to 1. If x is not equal to 0, then x is 1. And if x is not equal to 1, then x will be 1. So this is the first Boolean postulate. If x is not equal to 0, then x is 1. If x is not equal to 1, then x is 1. And the second one we have here is or relation, or we can also say that is a logical addition, or relation or logical addition. See, 0 or 0 will be 0. See, or operation, or symbol is this one. When we are giving two inputs 0 0, we are going to be get output as 0. We are going to be get output as 0. When we are giving 0 or 1, it will be 1. So the logical or symbol is this one. When we are giving 0 1, we are going to be get as 1. We are going to be get 1 as output. Next, 1 or 0 will be 1. So 1 we are passing here, 0 both are inputs, and we are going to get as 1. Next, 1 or 1 will be 1. So we are going to be consider OR gate. 1 1, if I'm giving, will be getting result as 1 only. And third Boolean postulate what we have is AND relations. Or we can also say that is a logical multiplication. This already we have discussed in the previous class. And operation, both are 1, then only it will be 1 and operation. Just for that we are going to be represented in terms of logic gate. 0 and 0 will be 0. See, logical and, if we are giving two inputs 0 0, then it is going to give as 0 as output. 0 and 1 will be 0. So I am going to be take logical and, if I am taking 0 here, 1 here, and will be getting the 0 as output. 1 and 0 will be 0. The logical and we are going to be take. So 1 0 we are going to be get as 0. So 1 and 1 it will be 1. So now AND operator 1 and 1 will be getting 1. So finally one more rule we have, that is complement rules. The fourth one we have here is complement rules. So 0 bar will be considered as 1. For the NOT gate, if I'm giving 0 as input, it is going to be give as 1. 1 bar if I'm giving, it will be getting as 0. The complement of 0 will be 1. Complement of 1 will be 0. So these are Boolean postulates of basic postulates of Boolean algebra. Principle of duality. Principle of duality. Most important question for 2 marks. Principle of duality along with an example. Most important question. Principle of duality. So what is principle of duality? Changing OR sign to the AND sign, changing AND sign to the OR sign, changing 0 by 1 and changing 1 by 0. See, the first rule we have here is changing each OR sign, to an AND sign. The second one, changing each AND sign to an OR sign. Right. Now, third rule, see, plus sign we have to change into AND sign, and AND sign we are going to be changed into plus sign, that is OR sign. Okay. Now, we are going to be changed 0 by 1 and 1 by 0. Changing each 0 by 1 and each 1 by 0. The example for this, so 0 or 1, 0 or 0 will be 0. See, applying principle of duality, this 0 will becomes as 1, R will becomes as AND, 0 will becomes as 1 and 0 will becomes as 1. 0 will becomes as 1. This is example we can consider for principle of duality. Any doubt in this, Pavitra? Next topic. Basic theorems of Boolean algebra. Basic theorems of Boolean algebra. Basic theorems of Boolean algebra. In that, first we have to discuss what is proof by perfect induction. Most important 1 mark question. What is proof by perfect induction. One mark important question. See, by substituting all possible values, we are going to be solve the theorem. It is a method of proving Boolean theorems by substituting all possible values of the variables. It is a method of proving Boolean theorems by substituting all the values of all the possible values of the variables. See, if we have a single variable x, what will be the possible values of that? We have 0, 1. By substituting that possible values of that particular variable, we are going to be prove it. We are going to be prove it. Right. Now see here. It is a method of proving Boolean theorem by substituting all possible values of the variables, all the possible values of the variables. Yes, any doubt with this proof by perfect induction?
No, sir.
Now see, properties of 0 and 1. First theorem, first basic theorems of Boolean algebra. First one we have is properties of 0 and 1. Properties of 0 and 1. Properties of 0 and 1. In that, the first property is 0 or x will be x. 0 or x will be x. See the logic gate for that, or symbol we have for the 0 and x. 0x will be getting the result as x only. Will be getting the result as x only. Is that clear? Now b 1 or x will be 1 or x will be 1. Or operator we are going to be take or operator we are going to be take 1 or x. So this OR gate will be getting 1. Will be getting 1. And C 0 and x will be 0. And operator. So 0 x will be 0. Next D 1 and x will be 1. 1 and x will be 1. So this is AND operator. This is AND operator. So these are the properties. We need to see the proof for each and every property. See, for this, how we are going to be show the proof? By using the proof by perfect induction. What is meant by proof by perfect induction? So by substituting all the possible values of the variables, we are going to be prove it. We are going to be prove it. Like I'll show you the proof. I'll show you the proof. proof. The first one, I'll take 0 or x will be x. How many variables we have here? Only one variable we have here. How many variables we have here? Only one variable. Now, proof for this is if x value will be 0, if we have only one variable, possible values are possible values are 0, 1. 0, 1. Am I right? See, if x is equals to 0, then first I'm taking the LHS. LHS is 0 or x. So in the x place, 0 or x. 0 or 0. 0 or 0 will be 0. 0 or 0 will be 0. See, in the same way, 0 value we have substituted for x. So because of that, that will be considered as x. Now, what we need, this is the RHS. This is the RHS. If x value is equals to 1, then LHS we are going to take 0 or x. X value we are going to be substitute as 1. 0 or 1 it will be 1. Where x value we have taken as 1. Where x value we have taken as 1. That is x. So that is RHS here again. So therefore we can say that 0 or x will be 0 or x will be x. 0 or x will be x. The same by using the truth table we can able to prove by perfect induction. This is proof by perfect induction. And next, the same by using the truth table. By using truth table also we can able to prove this. Zero x, 0 or x. So when we have this case, 0, 0, 0, 1. So 0 or 0 will be 0, 0 or 1 will be 1. So by observing the columns, x and 0 or x, both values are same. Therefore, 0 or x will be x. By using the proof by perfect induction, we have solved it. At the same time, by using the truth table also, we have solved it. Only the first one is completed now. The first property, 0 or x is equal to 0. So this is a proof by perfect induction. by substituting x value as 0, we are taken the LHS is 1 or x value we have substituted as 0. So we are getting 1 or 0 is 1, that is RHS. So if we are substituting x value is 1, we are taking the LHS 1 or x value we are substituting as 1 or 1 will be 1, which is RHS. So with that we can say that by using 2 by perfect induction 1 or x will be 1, and by using the truth table 1x 1 or x 1 0 1 1 or 1 is 1. So because of that we can say by observing the columns 1 and 1 or x, both the values are same. With that we can say this is proved.